The use of a red conductor as a grounding wire is a violation of the National Electrical Code, specifically the NEC Article 200.7. C4 states that uninsulated conductors, grounding conductors, and equipment grounding conductors shall be identified by a continuous green or green with one or more yellow stripes, color code or marking, or by other approved means. Furthermore, NEC Section 406.4 D specifically prohibits the use of a conductor or grounding conductor as a bonding conductor unless it is an insulated or covered conductor identified by green color or green with one or more yellow stripes. In this scenario, using the red conductor, which is normally used for the hot phase, as a grounding conductor and connecting it to the orange insulated ground receptacle is not permitted because the red conductor is not identified by a green color or green with one or more yellow stripes. To correct this violation, firstly, replace the red conductor with the green or green with one or more yellow stripes conductor. Secondly, connect the green conductor to the orange insulated ground receptacle. Thirdly, use the green wire as the bonding wire for the box. It is important to adhere to the NEC and local electrical codes to ensure the safety and proper functionality of all electrical installations. The National Electrical Code sets forth specific requirements for the identification and use of conductors in electrical systems. These requirements are in place to ensure safety and prevent potential hazards. When dealing with grounding conductors, the code mandates a clear and unambiguous identification method, which is primarily achieved through the use of color coding. The specific color code for grounding conductors is green or green with one or more yellow stripes. This color coding serves as a visual cue to electricians and other personnel, indicating that the conductor is intended for grounding purposes. The grounding system is a critical component of an electrical installation, providing a low impedance path for fault currents to return to the source. This path facilitates the operation of overcurrent protection devices, such as circuit breakers and fuses, which are designed to interrupt the flow of current in the event of a fault. A properly functioning grounding system helps to minimize the risk of electric shock and equipment damage. The NEC prohibition of using conductors of other colors, such as red, as grounding conductors is intended to prevent confusion and potential miswiring. If a red conductor is used as a grounding conductor, it could be mistaken for a hot conductor, which could lead to dangerous situations. For example, an electrician working on the system might inadvertently disconnect the red conductor, assuming that it is a hot conductor, which would interrupt the grounding path and create a shock hazard. The requirement that grounding conductors be green or green with one or more yellow stripes is a fundamental safety measure that helps to ensure the integrity and reliability of electrical systems. In addition to the color coding requirements, the NEC also specifies other requirements for grounding conductors, such as their size and installation methods. These requirements are designed to ensure that the grounding system is capable of carrying the expected fault currents and providing a low impedance path to ground. It is essential that all electrical work be performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. These professionals have the training and experience necessary to ensure that electrical systems are installed and maintained in a safe and compliant manner. When modifications or repairs are made to an existing electrical system, it is crucial to verify that the grounding system is properly connected and functioning correctly. This verification should include a visual inspection of the grounding conductors to ensure that they are properly identified and connected, as well as electrical testing to verify the integrity of the grounding path. In the specific scenario described, where a red conductor was used as a grounding conductor, the violation of the NEC must be corrected immediately. The red conductor should be disconnected from the insulated ground receptacle and replaced with a green or green with one or more yellow stripes conductor. The green conductor should then be properly connected to the insulated ground receptacle, and the green wire should be used as the bonding wire for the box. It is also important to inspect the rest of the electrical system to ensure that there are no other violations of the NEC or local electrical codes. Any additional violations should be corrected promptly to ensure the safety and proper functionality of the electrical installation. The National Electrical Code is a comprehensive set of standards that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is essential for electricians and other electrical professionals to stay up to date in the latest version of the NEC to ensure that their work is compliant with current standards. The NEC is a living document that is constantly evolving to address new challenges and improve the safety of electrical systems. By adhering to the NEC and local electrical codes, electricians can help to protect people and property from the hazards of electricity. In addition to the NEC, there may be local electrical codes that apply to specific jurisdictions. These local codes may be more stringent than the NEC, and it is important to comply with both the NEC and local codes when performing electrical work. Local electrical codes are typically enforced by local building departments, which may require permits and inspections for electrical work. It is important to obtain the necessary permits and inspections before starting any electrical work to ensure that the work is compliant with all applicable codes. Failure to comply with the NEC and local electrical codes can result in fines, penalties, and even legal action. More importantly, non-compliance can create dangerous situations that could lead to electric shock, fire, or other hazards. Therefore, it is essential to take electrical safety seriously and to follow all applicable codes and standards. In summary, the use of a red conductor as a grounding conductor is a clear violation of the NEC. This violation must be corrected immediately by replacing the red conductor with a green or green with one or more yellow striped conductor. It is also important to inspect the rest of the electrical system to ensure that there are no other violations of the NEC or local electrical codes. By adhering to the NEC and local electrical codes, electricians can help to protect people and property from the hazards of electricity. Electrical safety is a shared responsibility, and everyone should take steps to ensure that electrical systems are installed and maintained in a safe and compliant manner. This includes hiring qualified and licensed electricians, obtaining necessary permits and inspections, and following all applicable codes and standards. By working together, we can create a safer environment for ourselves and our communities. The importance of proper grounding in electrical systems cannot be overstated. Grounding provides a safe path for electrical current to flow in the event of a fault, protecting people and equipment from harm. A properly grounded system helps to prevent electric shock, reduce the risk of fire, and improve the overall reliability of electrical equipment. The NEC provides detailed requirements for grounding systems, covering topics such as grounding electrode systems, grounding conductors, and equipment grounding. It is essential to follow these requirements carefully to ensure that the grounding system is properly installed and functioning correctly. Grounding electrode systems typically consist of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete tin-cased electrodes. These electrodes are connected to the grounding system and provide a path for electrical current to flow into the earth. Grounding conductors are used to connect the grounding electrodes to the electrical equipment and systems. These conductors must be sized appropriately to carry the expected fault currents and must be installed in a manner that minimizes impedance. Equipment grounding refers to the connection of non-current carrying metal parts of electrical equipment to the grounding system. This helps to prevent these parts from becoming energized in the event of a fault, which could create a shock hazard. The NEC requires that all electrical equipment be properly grounded, and it provides detailed requirements for equipment grounding conductors and methods. In addition to the NEC, there are other standards and best practices that can be used to improve the safety and reliability of electrical systems. These include standards from organizations such as the Institute of Electrical and Electronics Engineers and the National Fire Protection Association. It is important to stay informed about these standards and best practices and to incorporate them into your electrical work. Electrical safety is an ongoing process, and it requires continuous learning and improvement. By staying up to date on the latest codes, standards, and best practices, Electricians can help to ensure that electrical systems are installed and maintained in a safe and compliant manner. Remember to always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable codes and standards. Take your time and double-check your work. If you are not sure about something, ask for help. Electrical work can be dangerous, but by following these safety precautions, you can minimize the risk of accidents. The consequences of electrical accidents can be severe, ranging from minor injuries to fatalities. Electrical shocks can cause burns, muscle contractions, and even cardiac arrest. Electrical fires can cause significant property damage and can also lead to injuries or fatalities. It is important to take electrical safety seriously and to do everything possible to prevent electrical accidents. This includes educating yourself about electrical hazards, following safety precautions, and hiring qualified and licensed electricians to perform electrical work. By working together, we can create a safer environment for ourselves and our communities.